Rational root theorem. Given a polynomial p of x is equal to a sub n times x raised to n plus a sub n minus 1 times x raised to n minus 1 plus a sub 1 plus a sub 0 with integral coefficients. And p over q is its rational 0. Then p is a factor of the constant a sub 0 and q is a factor of the leading coefficient a sub n. So we'll be focusing here on the a sub n, which is the numerical coefficient of our leading term, and it is represented by q. And our a sub 0, that is represented by p, and that is our constant in our given polynomials. Let us take this given example number 1. Enumerate all the possible rational zeros of p of x is equal to 2x cubed minus 7x squared plus x plus 10, applying the rational root theorem. In step 1, we're going to write all the possible factors of our a sub 0, which is represented by p. And in this case, our a sub 0 here is 10. So the possible factors of 10 are positive 1, positive 2, positive 5, positive 10. So we'll also consider the negative numbers because negative 1 times negative 10 is also positive 10, similar to positive 1 times positive 10. Negative 2 times negative 5 is 10, which is also similar to positive 2 times positive 5, which is also 10. So in this case, we are considering both positive and negative factors. Then after writing or listing down all the factors of the constant a sub 0, we're going to write also the factors of the a sub n, or which is represented by q, and in this case, that is the 2. So the factors of 2 are positive 1 times positive 2, and also negative 1 times negative 2, and they're both equal to 2. We will then write this p over q, this p and q into its ratio form p over q, because this represents the rational 0. So our p here is this one, plus minus 1, plus minus 2, plus minus 5, plus minus 10, and our q is plus minus 1 and plus minus 2. So we're going to write this in p over q form. So we will be writing all the factors of the constant, which is represented by p in the numerator, then q in the denominator, and we are now ready to list down all the possible rational zeros of this given. So let's get started. So positive 1 times positive 1, so that is positive 1. Negative 1 times negative 1, or positive 1, so that is negative 1. Then this negative 1 multiplied to positive 1, this gives us negative 1, so we don't need to write it again. Then negative 1 times negative 1 is positive 1, so no need for us to write it again because it's already here. We will go now to the plus minus 1 divided by plus minus 2. So positive 1 times divided by positive 2 is positive 1/2. Positive 1 divided by negative 2, that is negative 1/2. Then negative 1 divided by positive 2 is still negative 1/2, so we don't need to write it again. And negative 1 divided by negative 2, that is positive 1/2, so we will not write it again because it's already here. Then we will do the same process in all the numerators by dividing this plus minus 1 and plus minus 2. So in plus minus 2 divided by plus minus 1, this gives us positive 2 and negative 2. So plus minus 2 divided by plus minus 1. So this gives us, we don't need to write it again because it's already here. That is positive 1 and negative 1. So plus minus 5 divided by plus minus 1. So that is positive 5 and negative 5. Then plus minus 5 divided by plus minus 2. This gives us positive 5/2 and negative 5/2. And lastly, plus minus 10 divided by plus minus 1. This gives us positive 10 and negative 10. Then plus minus 10 divided by plus minus 2. This gives us positive 5 and negative 5. So we will not write it again. And these are all the lists of the possible rational zeros. So the set of this one is the possible rational zeros of this given. We can also write this answer into this form. So we are combining positive 1 and negative 1 into plus minus 1. Then positive 1 half and negative 1 half, we can combine this into plus 1 minus 1 half, and so on and so forth, so that we can save space in our answer. In our given number 2, enumerate all the possible rational zeros of p of x is equal to x cubed plus x minus 12, applying the rational root theorem. So again, we will start writing the a sub 0. So the factors of a sub 0, in this case, that is negative 12, and that is represented by p. So the possible factors of negative 12 are 1, 2, 3, 4, 6, 12. So positive 1 times negative 12 is negative 12. So negative 1 times positive 12 is also negative 12, and so on. Then we will write the factors of our a sub n. So that is the numerical coefficient of our leading term. So in this case, it's x cubed. Its numerical coefficient is 1. So what are the factors of 1? It is plus and minus 1, because positive 1 times positive 1 is 1. Negative 1 times negative 1 is 1. Then we're going to write these factors into p over q. So expressing it into p over q is getting its rational 0. So after listing them down, we're going to write it into p over q. Then we will now be dividing all the numerators by the denominators for us to enumerate all the possible rational zeros. Let's start with plus minus 1 divided by plus minus 1, and this gives us positive 1 and negative 1. So plus minus 2 divided by plus minus 1, this gives us positive 2 and negative 2. Plus minus 3 divided by plus minus 1, this gives us positive 3 and negative 3. So plus minus 4 divided by plus minus 1 is positive 4 and negative 4. Plus minus 6 and divided by plus minus 1 gives us positive 6 and negative 6. And lastly, plus minus 12 divided by plus minus 1 is positive 12 and negative 12. And this is the set of our possible rational zeros. And this is our answer. We can also write this into this form, plus minus 1, combining the positive and negative numbers. So plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, and plus minus 12. And this is our answer.